Good afternoon.
Hey, Mr. Strong.
How are you doing today?
Good, how are you?
Well, I'm okay, except my computer here is not wanting to work. So I'm a little bit stressed about that. And there's Jada. How are you, Jada?
What? Oh, I'm good.
Okay. Let me see if I can reboot the system here. Let's see here. All right, let's try this again. All right, we still don't have Toby. Okay, we got something going on. Let's see if it'll. So, do you guys have any questions or anything before we get started? All right, looks good now. Okay. Okay. All right, let's try this. Okay, let's see. Wow, this computer's having some problems here today. All right, so, wow. Okay, so today we're going to do 11.6 on conic sections. Again, there's no calculus in this section. It's just a kind of a review of actually chapter 9 in Trig from last year. So, but it's just a quick review. Again, it's very helpful when you take Calc 3 if you just kind of know about the conic sections or polar coordinates and some of the stuff that we've been going over, parametrics and so on. All right, so and then did I talk about the quizzes in chapter 11?
Yeah, you did.
Okay, so sorry. So instead of one every section, I'm just doing two. One over the first part and one over the second part. So anyway, so you can be looking for those. I'll probably unlock the first one if I haven't already. I'll probably do that today. Let's see. And then tomorrow we're going to talk about Monday's class. Remember, I'm going to have you kind of decide which would be most beneficial to you, to have a review day or a Moodle day. And I'm good with either one. So you just we'll just talk about it more tomorrow. Okay? So anything else before we get started on 11.6? All right, well, let's do it. Okay. So this section is, like I said, this is on conic sections. So, so just to kind of, well, first of all, let me just say, if you look at the guided notes for this section, I just felt like there was just a lot of vocabulary in this section. So you'll notice almost the entire first page is just vocabulary. So again, it would be a good idea to review that vocabulary. We're going to do some along the way, but so a conic section or a conic is the intersection of a plane with a double napped cone. So let me kind of show you what that looks like. So the double napped cone, that means the two cones that are together point to point. And so if a plane intersects it parallel to the base, then that forms a circle. If the plane is tilted at a little bit of an angle, then that's going to form an ellipse. If the plane intersects through the base of one of the cones, it forms a parabola. If it goes through both bases, then it's a hyperbola. And so, hey, Tobias, good to see you. So these are normally what we call the conic sections. Now, these last three are what we call degenerate conics. And so you begin studying that this is, if the plane goes through the vertex here in the middle, then it just is a point. Or if it goes through the edge, then it's a line. Or if it goes through the two edges, then it could be a intersecting lines. So points, lines, and intersecting lines, you started studying that in pre-algebra. So that's not the focus here. When we talk about studying conic sections, these are the four. And really, we've discussed circles enough in both Math 152, 189, and Calc 1 when we do not only parametric equations, but implicit differentiation. We deal with circles. And so the focus of this section are these last three: ellipses, parabolas, and hyperbolas. Okay? All right. So there's just a little, kind of a quick little review for each of those three. So starting with a parabola. So the definition of a parabola is, like you start with the circle. A circle is the set of all the points in a plane that's an exact distance from the center point. Okay? Well, so here's like a circle. A parabola is the set of all points that are equidistant, so the same distance from a point and a line. Okay? Now, usually that's not how we, when you study it in Algebra 2, you don't talk about a parabola in those terms. But here we are, because we're going to be talking about the focus for all of the conic sections. So whatever the distance, so the point is the focus. The line, we call that the directrix. Okay? So you have the vertex of the parabola, and whatever that distance here is to the focus, you have that same distance to the directrix. So for any point on the parabola, this distance here is the same as this distance here. Okay? Now, the line that cuts the parabola in half, that passes through both the focus and the vertex, that's called the axis, or the axis of symmetry, because one side is symmetrical to the other. Now, we use P to represent the distance from the vertex to the focus. And P is what we call a directed distance. So if it's positive, you measure up to the focus. If P is negative, you measure down to the focus, and the parabola would open down. The focus, it's kind of like the parabolic dish. The focus is like the amplifier or the microphone. And so the focus is always on the inside of the parabola, okay, whether it opens up or down. And then once you figure out this distance to the focus, that same distance in the other direction is the distance to the directrix, which is the line, okay? Okay, so these are the notes, finally. Excuse me. So I know this is the equation for the vertex that we use in Math 152, but these are the four equations that we use really in trig and in calculus. All right? Now, so in each case, the vertex is at hk. So you have x minus h squared equals 4p y minus k. Now, if the x term, if this term is squared, then it's a vertical opening parabola. It either opens up or it opens down. If the y part is squared, that you have y minus k squared equals 4p x minus h. If the y part is squared, then the parabola opens left or right. So we say it has a horizontal opening or a horizontal axis. Still, HK is the vertex, okay? The focus lies on the axis P units, directed distance from the vertex. So whatever the number is in front here, you set that equal to 4P and solve for P. And that's how you find the focus and the directrix. And we'll do one of those in just a minute. Now, these two equations in standard form simplify considerably if the vertex is at the origin, because then both your h and your k go away, and so you just get x squared equals 4py, y squared equals 4px. And so, if x is squared, you have a vertical axis, it opens up and down. If the y is squared, you have a horizontal axis, it opens right and left, right or left. All right, so any questions on any of that? Okay, so again, once you have the vertex, then when you find P, if P is positive, then you go up, and then your parabola will open up. If your P is negative, you'll go down, and then your parabola will open down. So once you realize it's a vertical parabola, then the P is going to tell you which way it opens. Now, if it's the y that's squared, then it opens left and right. And so then if you have a positive P, then you'll measure over to the right, and your parabola will open to the right. If the P is negative, you'll go to the left, and then the parabola will open to the left. So whichever way you do the focus first, and then you measure the same distance in the opposite direction to get the directrix. So the directrix is the line. So if it's vertical, its equation is x equals. If the directrix is horizontal, its equation is y equals whatever. Okay? All right. So this says find the focus and the directrix of the parabola y squared equals 10x. Okay? So this is kind of how you go through it. You say, all right, so what's the the vertex of this? Well, there's no h and k. There's no numbers with the x and y. So in this case, the vertex is 0, 0. But if you had like x minus 2 and y plus 3, then you change those signs, just like with circles and so on. You change the signs of the numbers. So you find the center first. Okay? All right, so let's see. Where do I have? Okay, so the center, let's go ahead and write that down. So the center is at 0, 0. All right, next you think, well, okay, so if it's the y that's squared, then that means the parabola opens horizontally. So left or right. Okay? All right, next. To get the p, the distance to the focus, you take whatever number here is in front of the unsquared term and set that equal to 4p. So you say, because this is the standard form that you wrote down at the bottom of the first column on your paper. So y squared is 4px. So you take the 10 and set that equal, you set that equal to 4p and solve. So you get 4p is equal to 10, so p is equal to 5 halves. All right, and it's positive. So that means from the origin, 0, 0, you're going to count over 5 halves, so 2.5. So the focus is at 5 halves, 0, and the parabola opens to the right. If the p was negative, then you would count over the other direction and the parabola would open to the left. All right, now the last thing we want to do is find the equation for the directrix. Since the directrix is the same distance from the vertex, so it's over 2.5 or 5 halves to the left, it's a vertical line, so its equation is x equals negative 5 halves. All right, so any questions on any of that? All right, so go ahead and try practice 1 there on the paper. Okay, so Weston, what's the vertex? You know what? I think I wrote center on this. Yeah, it's not the center; it's the vertex, is what we find first here. We're not doing circles here. So what's the vertex for this one?
0, 0.
It's also 0, 0. Okay, so you could even think of this as x minus 0 squared equals negative 6 times y minus 0. And so the vertex is 0, 0. All right, so Jada, does this parabola open horizontally or vertically?
Vertically.
It opens vertically because the x is squared. Okay, so it opens up or down. All right, Toby, what's the p?
I got negative 3 halves.
You got it right. So you say 4p is negative 6, so p is negative 3 halves. All right, so Weston, what is the focus?
0, negative 3 halves.
0, negative 3 halves. Jada, does the parabola open up or down?
Sorry, this button doesn't work. Down.
Down. Because here's the vertex. You go down to find the focus, the focus is always on the inside of the parabola. So the parabola is going to open around it. So it's going to open down. Okay? And let's see, Weston, what is the, or wait, was it Toby's turn? I'd lost track now. Weston, what is the equation of the directrix?
Y equals 3/2.
So it would be y equals 3/2. Very good. Okay? Any questions? So that's the quick and dirty review of parabolas. We're moving on. All right? That's all we're going to do here. Okay? So now we're going to go on to ellipses. So we're going to kind of do the same thing. Give you the standard forms and so on. Okay? All right, so what is an ellipse? An ellipse, like the circle is the set of all points that are given distance from a center. The ellipse is the set of all points that are given distance from the sum of the two distances from 2 points. So these 2 points, the foci, if you add up these distances as you go around, that sum will always be the same. Okay? And you still have a center, and kind of the long measurement across is the major axis. The smaller one is the minor axis, and then the ends of the major axis are the vertices or vertexes. Okay? Okay, so here's the standard equation of the ellipse. All right, now, really, I'll just tell you, every book I've seen has these two, where they talk about the major axis is horizontal or vertical. But if you look, the difference is that what determines whether your ellipse is horizontal or vertical, fat or thin, is which of these numbers is bigger. So I really only memorized one of these. I mean, I know one of these, and I don't even think about that there's other versions of it. And I just say, okay, I look at the ellipse, find the center is at HK, and then whichever one of these is bigger is going to determine the shape of it. And so the number underneath the X tells me that the A tells me how far to go left and right. The B tells me how far to go up and down. Or the number underneath the Y tells you how far to go up and down. Now, if the center is at 0, 0, then these two simplify again considerably to these two. And again, how I just remember the major axis being vertical or horizontal is which number on the bottom is bigger is going to determine that. Now, so the other equation you really need to write down is this one here. Is it says the foci lie on the major axis, C units from the center, with C squared equals A squared minus B squared. So you might want to write that. I was just kind of making a note to myself to add another line for that formula, because you're often asked to find the foci. Okay? So it's C squared equals A squared minus B squared, where you just subtract the bigger one of these numbers minus the smaller one, and then take the square root. And then that's going to be the C. So you'll see it's not really all that tough to find C. Okay? All right, so let's do an example here. Well, let's just keep going. All right, so this is graph the ellipse and find the foci. So again, the first step is you find the center. In this case, the center is at 0, 0. But if we had like x minus 2, x plus 5, again, you change the signs in 2, negative 5, or whatever. Here, again, the center is at 0, 0. Then from that point, you use the numbers under here to find, you're going to find 4 points that will help you graph. So underneath the x, the square root of 16 is 4. So from the center in the x direction, you're going to go left and right 4 units. And then the number underneath the y is the square root of 9 is 3, plus or minus 3. So you're going to go up 3 and down 3. And then you just connect those dots in circular fashion, elliptical fashion, I guess I should say. And that's the graph. Okay? So ellipses are super easy. Now, to find the C, the foci, it's a little bit, more. You have to use that formula. C squared equals A squared minus B squared. So it's just this minus this. So 16 minus 9, or the bigger one minus the smaller one. And so you get C squared is 7. So C is plus or minus radical 7. So then along the major axis, so this is the horizontal one, you're going to add and subtract radical 7 from the center point. Now, since it's horizontal, you're going to add and subtract to the x value only, because you're moving to the left and to the right. So your foci are negative radical 7, comma 0, and then when I add radical 7, I get radical 7, comma 0. And so those are my foci. And so you add, so let's say if the center was at 1, 3, then you would add radical 7 to the 1. So it'd be 1 minus radical 7, 1 plus radical 7. Okay? If your ellipse is vertical, then you add and subtract from the y value. Okay? All right, so let's see if you can do practice 2. Okay, so, all right, so Weston, what is the center?
2, negative 1.
2, negative 1. All right, and then, Toby, in the x direction, we go over how far from that center point?
3.
3. Jada, from the center point we go up and down, how far?
4.
4. Okay, so our graph is going to look like this. So you do the center point, left and right 3, up and down 4, boom. Okay. All right, Weston, what is C? Little c. The distance. The distance from the center to the foci.
The square root of 7.
Square root of 7 again. Okay? It's not always going to be that, but okay. So, Tobias, what are the coordinates of the two foci then? It's F1 and F2.
I'm not really exactly sure because it's like I don't know what the square root of 7 is, but I guess I could.
You can leave it as a square root of 7.
Okay, so would it be like the square root of 7 minus 1 for like 2 comma the square root of 7 minus 1 or something like that? For
Okay,
the bottom?
so that would be up here.
Yeah.
And how about this one?
What, negative square root of 7 minus 1?
Yeah. So the way that you can say that together is just 2, -1, and then plus or minus radical 7. So if you put that second, then you can do the plus or minus thing, and so then it goes up for plus, down for minus. Okay? So that's kind of a shorthand way to put both answers together. Okay? All right, any questions on that? All right, so that is ellipses. Okay? All right, now, the last one is the hyperbola. To make the equation for the hyperbola, all I have to do is change the plus in the middle to a minus. That's it. And it's a hyperbola. Okay? Now, the definition of the hyperbola is that it's the difference of the two distances that is constant. Okay, let me show you a picture here. It's a little easier to understand. Okay, okay. So if you take any point on the hyperbola, and the hyperbola looks like two parabolas back to back. And so you take any point on the hyperbola, and if you take the distances between the two foci and subtract them, that common difference is the same. Okay? Now, you still have a center, you still have the vertices, and you still have foci. Okay? Let's see. So let's look at the standard forms. Again, these are going to look very similar to the equations for the ellipse. Okay? The big difference is the minus in the middle. You still have the center at HK, but since it is a minus, that whichever one of these terms comes first is going to matter, because with the ellipses, you're adding, so the order didn't matter. But here, if the x squared comes first, if the x term is squared minus the y term is squared, then your hyperbola is going to open left and right. It'll open horizontally. If the y part is squared, if that part comes first, then the hyperbola opens up and down. And then once again, if the center of the hyperbola is at 0, 0, then the h and the k's go away. And so you're just left with these two simplified equations. Now, the formula to find c is slightly different. Instead of c squared equals a squared minus b squared, it's plus. And so with the ellipse, it's plus in the middle up here and minus to find the c. For the hyperbola, it's minus up here and plus to find the c. Now, I also want you to write one more equation at the bottom that I also left a blank for, and that's to find the equation of the asymptotes, and that's y equals plus or minus b over a times x. Okay. All right, so going through and graphing these, at first it feels like you're graphing an ellipse, but it doesn't look like it at the end. Okay? So, because the hyperbolas end up like this. So like I said, they look like two parabolas back to back. So if the x squared is first, they open horizontally. If the y squared is first, they open vertically. Okay, so let me explain how we do this. All right, so the first thing you do is you look, so here's the equation that we're going to start off with. So just pretend for a second that you're drawing an ellipse. Okay? So you find the center, there's no h and k, so the center is at 0, 0. So that's where you start. Okay? Then in the x direction, you go over the square root of 4, which is 2. So 1, 2, so you get that point, 1, 2, you get this point. All right? In the y direction, you go over the square root of 5, so a little bit more than 2. So you go up here and you get this, and you go down here and get this. Okay? Now, if we were doing an ellipse, so if we just had this be a plus, then we would just connect those 4 dots and be done with our ellipse. Okay? But with a hyperbola, what you do is you take the 4 dots, and instead of making an ellipse out of them, what you do is you make a box that contains those 4 points. And then you do the diagonals of the box. And so that's all this dotted line mess. Now, the reason why we make it dotted is technically it's not the hyperbola, it's just how we get it. And then you say, okay, the x squared comes first, so then from these 2 dots on the side, I'm going to make it open left and right. Okay? And if the y squared was first, then we would go up and down. And so you approach those asymptotes. Okay? All right. And so all of this that's here in green is just to help you draw it. The part that's the actual hyperbola are just these blue curves right here. Okay? All right. So let's see if you can, and then to get the equation of the asymptotes, it's plus or minus, y equals plus or minus, okay, so the square root of this, 5, over the square root of this, 2. So y equals plus or minus radical 5 over 2. Those are the equations of the asymptotes. Okay? All right, so see if you can do practice 3, please. Oh, and there is a typo on that. That in the middle, x squared divided by 4, it has to be a minus or it's not a hyperbola. So take that plus out and make it a minus. All right. Well, I guess let's just show the graph. Is that kind of what we got for the graph of the hyperbola? Any questions, concerns, worries, anything you don't understand about graphing the hyperbola? Any problems with that? So the center again is at 0, 0 here. It opens left and right because the x squared comes first. We go 2 in the x direction, 4 in the y direction. Make the box the diagonals of the box. Okay? All right, so Jada, what are the equations of the asymptotes?
I'm not sure. I think I messed up.
Okay, so you start off, it's always going to be y equals plus or minus, and then you take the square root of the number underneath the y. So what's the square root of that?
4.
Over the square root of the number under the x. And so what would that be?
2.
2. And so it's going to be plus or minus, or y equals plus or minus, whoops, 4 over 2x. And then that simplifies to y equals plus or minus 2x. Okay? All right, any questions on that? Okay. So that's pretty much it for our quick and dirty review. So now we're going to talk about the last thing we're going to finish up with here today is determining the type of conic section based strictly on the equation. All right, so this is when the equation's multiplied out, then see it's actually of the form, I guess I should write out the whole thing. So ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Okay, so that's a lot. But really, to identify the conic section, all you need to look at is the a and the c. Okay, so you don't even need the rest of those numbers. So you're looking at the coefficient of the squared terms. Now, if those two coefficients are equal, then you have a circle. All right, then if you multiply them together and get 0, then that means you have a parabola. So in other words, if one of them doesn't exist or doesn't show up, then that's like saying you have a 0 for the coefficient. So if you have one squared term, that's another way to think about it, you have a parabola. All right, then if you multiply the a and the c together and you get a positive number, then it's 0. I mean, a positive number greater than 0, then it's an ellipse. And if you multiply them together and get a negative, that means one's positive and one's negative, then you get a hyperbola. Okay? So then to do this, you just say, okay, what conic section does this represent? All right, so you just look at these two squared terms. They're not equal, so it's not a circle. They both you have both square terms, so it's not a parabola. So then when you multiply 1 times -4, you get -4. So if you get a negative, then that means you have a hyperbola. Okay? All right. So do that last practice 4. See if you can figure out what type of conic section you have just based on the equation. All right, so Toby, what do you think?
An ellipse.
An ellipse is correct. Okay. Any questions on that? All right, so it is kind of weird to be finishing up Calc 2 with these lessons that don't involve any calculus at all. But again, it's to help you, get ready for Calc 3 if you decide to go that route. So, but that's it for as far as our material for today. Does anyone have any questions or anything you want me to go over? Okay, so tomorrow we will finish the last section. Okay, hopefully we'll finish it, but we'll certainly start it. Our last section of new material for the whole class. So big day tomorrow. All right, so anything before we call it? All right, well, you guys, thanks for working hard. Have a great day. We'll see you tomorrow.